Start the slideshow. Yeah, I'm Bern. I'm software engineer at Oasis, and yes, I will talk about the Oasis and especially Oasis ROFL, and guide you through a quick demo how you can get up an app running. You will find quite some similarities to DStack. I will try to cut it short in that regard, but we'll focus like what we do. In the end, yes, we are a bit more opinionated than DStack and have maybe some batteries more included. But yeah, this has both its pros and cons. Yeah, to the agenda, I will talk about the Oasis demo, and then like also the app-D, which like has additional features. And then, yeah, if there's some questions, we can talk about that. The first thing, quick recap for people who are not familiar with Oasis. We are on a layer 1 blockchain. We have a consensus layer and more or less like compute layer. The consensus layer is a basic stack for consensus. And then like the more important one is like Sapphire, our confidential EVM, and the ROFL apps, which kind of dock onto Sapphire. How does this look like for a developer? Like we have kind of the Oasis SDK. So like you have smart contracts, which is the Sapphire ecosystem. We have libraries for front-end development for contracts to have encrypted transactions. You can also call like Sapphire libraries on your backend centralized, but yeah, the more important one is then the ROFL Power Apps, so you can actually deploy your backend and your front end in a TEE. Quick recap to Solidity, or like to Sapphire and Solidity. Like we have kind of a EVM smart contract chain where we have the smart contract storage encrypted. All smart contracts are executed in the TEE, so like only in the TEE. The TEE will get an encryption key over a key manager and can do the computation. And all smart contract transactions can be encrypted, so you don't see what was sent exactly to the blockchain. The computation is done in the TEE. You cannot see into it, and like it's written down encrypted. Like this, you have a confidential EVM, and like we have also some threshold precompiles for key derivation, encryption, and also like connection actually then to the ROFL powered apps. I will come in a minute. But yeah, if you only use the Sapphire part, yeah, you will be still limited to to the normal blockchain constraints. You have now, yeah, well, I will come in a minute also. So that's why we have the ROFL powered apps. What are the ROFL powered apps? Like they are actually run in this ROFL nodes. So like here you can see the architecture in it, like you deploy your containers similar with the DStack in this ROFL node. And like in this ROFL node, you have then automatically like light client to Sapphire. So you can post transactions to Sapphire and read state from Sapphire. You have attestations, and the attestations are directly already put on the Sapphire blockchain. You don't have to do any for that. Like this happens automatically. If you change anything in your ROFL app, you always have to sign these transactions, and they will be written onto Sapphire. And then like the other cool thing is like we have this app-D sidecar, which lets you actually use a key manager directly into your containers, and like also post directly to Sapphire, and this is verifiable in our stack. Yeah, to actually ROFLize your apps, how do you do that? Wait, there's a slide missing. Okay. Where is this slide? Oh, this slide is here. I removed the wrong slide to the bottom. Yeah, So what can you do actually with ROFL? What you can do with Sapphire alone? You can do verifiable compute. You can actually call external services, and you can do cross-chain execution also. Like even though like we have a boundary, like a easy access to Sapphire via the Sapphire Lite client, you still can use the ROFL apps to do things on all chains. So either you can get it from the Web 2, but also from Web 3. You can kind of run everything trusted in this TEEs. And you can run continuous operations. Like if you just use the chain, you have only triggers, like if a transaction comes in. If you run it in ROFL, you can run it as a daemon, run loops, whatever. And you have like the key manager where you don't need to use the chain, but you can kind of have a key manager simple by calling an API. Then how you actually ROFLize your app. I mean, this is similar to the D-Stack. You will need an app which has a Docker Compose file. I can note here, like you can also run it actually raw, but like, with TDX, the preferred way is doing it with containers. You need an app image available in a public URL, some test or roast token to deploy the machine. And like the CLI is the easiest way to deploy this. We have also a website, but like in general, as a developer, I will recommend to use on our site the CLI. In the CLI, you have more or less 5 steps to get it running. The first one is the init command, which like just generates a YAML file in your folder. Then you have the create command, which registers the app on-chain, means you get an app ID, and this is a unique ID you get on the testnet or the mainnet. Then you build your ROFL bundle. This means like it actually creates a bundle of your compose file and all the data you have in your YAML, means like the name, the version there, and everything. Then you have to update that on-chain. So like the bundle information will come on-chain. And then as the 5th step, you deploy more or less the bundle, which uses then the update, the enclave ID from the update, and then you have it running. You deploy on our more or less marketplace. We have providers running from ourselves, from the foundations, where you deploy the apps onto, or mainnet. We have also different providers which you can select. At the end, this is also that the developer can say, I only trust this marketplace, or like I run my own provider and I only deploy to my provider because I know this runs in a data center I trust, and there is no misuse or anything. Then I will do a quick demo of what you can build and how to use actually all these commands. I built kind of a simple, like a tested signing demo, which is a Python app which gets weather data, signs the weather data, and writes it down on a smart contract. And then in a smart contract, actually anyone can confirm that this data and was with a signature which came from the TE. Which the demo has then 2 components. One is the smart contract, which is on Sapphire, which lets you verify the signed data. And you have the Python app, which then is ROFLized, which will register the signer and also then post the data onto the smart contract. How does this look like? Where are we here? We can see now the code. So I will start with the contract quickly. It is a normal Solidity contract. The important part is that we register the smart contract with the ROFL app ID. that we can then use a modifier to only let calls which came from this ROFL ID to write specific functions. The subcall is a precompile, and you can import it from our smart contract library, and obviously the subcall will only work on Sapphire. So like if you want to use the direct kind of verifiability that the call came from our ROFLized app, the easiest way is to use the Sapphire network for that. So this modifier is then used that only like the registered signer can be set from inside ROFL, and also the data can only be submitted via inside ROFL. And then, you have the verified data, which everyone can call, which then will recover the signer of the data, so that you can check that the data was actually signed by the correct address. On the app side, the important part is like, we have also a ROFL client, which makes things easier to use. What we will do in this Python app is at the end, we use our client to generate the key. So we use the key manager bundled with the ROFL. We'll create a private key and set this address as the registered signer. And then we will actually run a loop, which will get weather data, then signs this weather data, and then uses here the client and sign submit to send the data to the smart contract. So going back to recap for the developers, what you have to do at the end, like for this demo, it's kind of like 10 or 11 steps what you can do to get it running. I will quickly run through them that you can see how this works. So I'm in the root folder. So the first thing I will do is, I need, obviously, as I said before, having the Oasis CLI running and have a account set up. And then the first thing I do is Oasis ROFL init. This will create this ROFL YAML file. And here, this is just the bare bones. It will have a name, initial version, and like the resources, which you can then adapt to your app. The next thing is Oasis ROFL create. This uses my account to register the app on-chain. So you have to sign a transaction for that. After the transaction is now posted on-chain, I got a ROFL app ID, which I will need to use for deploying the contract. So actually, the next thing I will do is go into the contracts. Then I will quickly update my environment where we're able to use that. And then I can run the deployment of smart contracts. So this command now deploys the contract on the Sapphire testnet. I'll get the contract ID here and the contract address. here. So I need this later for in the validation. So I'll set this as the environment. Then next I will go back to the root folder, and as said before, now we have done the init, create and deploy contract. So now we actually set as a secret the contract address. This ROFL secret sets. We have also a function that you can directly import the whole .env, but yeah, at the moment I only need the contract address here. Then as next is ROFL build. Maybe quick to the compose file. This is how the compose file looks like. I have the image already built and pushed to the repo, to the container registry. We have also, as similar as dstack, a socket running, and the socket running is the API for our app-d, where you have the KMS and like this sign and submit functionality. So yeah, we will deploy this compose file. Obviously, if you want to have like verifiability that there was not the latest just updated and the server restarted, you would obviously pin the hash of the image here in your compose file. So after then building that, you want to update your bundle information on-chain, and also push the encrypted secret you set before on-chain. That you do with Oasis ROFL update. That's again assigning a transaction on-chain. And now you can do Oasis ROFL deploy. This deploys now the OCR, the bundle, to the provider. This can take a while, so I will go quickly back here. We are now at step 8. In a minute, I will check how the machine is running and look at the logs, and then look if we can verify the data. In the meanwhile, a quick recap to the app-d. So the app-d has multiple endpoints. Like the first one is the keys generate. With this, you can generate keys, obviously. We have the client SDK to do that also. Then we have sign and submit. This is the sign and submit transaction to can then validate via the subcall. Also have that in the client SDK. And then we have also other endpoints. One is the ID and the metadata. So for metadata, you can actually enrich on-chain metadata for your ROFL app. This can be helpful, especially for 8004, for example, that you can set your identity there. And yeah, the secrets are the other part which you can update in your app. That seems a bit slow, but yeah, it's working. Anything else I can show? Meantime, maybe I can show this or our Explorer. This works now. Okay, this works now. Okay. Yeah, in the meantime, like we have also ROFL.app. There you can see like all your apps you are deploying to. So this is actually the one I deployed. You can set new secrets there also via the GUI. But yes, so it's not deployed. Super slow. Yeah. I don't know what I can then. Yeah, like yeah, I will go further with the presentation. What you can do now with that bundle, more or less. I also like have here maybe some reference from the papers which was talked yesterday about. Like yeah, what you can do now with this combination is like yeah, you can for props like you can swap the weather API for ML models and post like a tested predictions. You can hold keys and credentials in the TE and have like policies on the Sapphire contract for recalls or something like this. You can monitor order flow and sign protected transactions. Liquefaction is actually the main, like the demo implementation also with Take My Ape from kernel is built on top of Sapphire. So like it uses the Sapphire smart contract chain to have this encumbered wallets. And yeah, you can build on top of this encumbered wallet system. And in general, like yeah, with DStack or with Oasis, you have at the end like a sandbox, so a TE sandbox where you can kind of process confidential data and yeah, publish only results. And I also was quickly saying something about 8004 agents. Like yeah, you can actually yeah have the KMS to generate the keys for your agent, so he actually can also register himself as an agent. We have also other demo apps for 8004 and X402 where you can look and if you're interested in building at that. I quickly check if it is still not deployed yet. To the question, do you know the location of the different TE worker nodes? Curious what all can see from Explorer. Yes, let me check that. For the providers, can see where do I have the there is this command, where is it? Yeah, I mean, there's a command in the CLI where you can see all the providers. I don't know if you can see the IPs for that. And I don't know, yeah, if I go now here actually to the machine. Yeah, each machine gets its own proxy. Like I actually don't think there is a registry where you can see all the registered apps. I would like to show something in the Explorer, but there's at the moment just an issue, so I can not actually show you the attestations from. Oh no! Okay, now it's online. Okay, now I can actually show that. Or is it not? Oh, okay, it's only old data. But yeah, I can maybe show from some other apps how it looks like. Yeah, from our price oracle maybe. This is how you can inspect the ROFL apps who run in the ROFL. You have like all the transactions here which are done from the ROFLized app. So like it actually registered liveness kind of every hour. It registered its on-chain, that it still runs with the same configuration. And you will have also like here any transaction I did before with updating and deploying new bundles. This is you will all see here on the page. So like if there's some change, and you monitor here the app, you will see that there is some change. On the attestations details, like the SEC public key and stuff, is also listed here, and the enclave IDs also. Yes. And yeah, then it's running now. So let's go to the contracts and run verify. And yeah, this is now the verify. So the attested signer is here, and like the check checks that the verification on the easy recover and gives you the same signer which was set. Yes, that's about the quick demonstration. Yeah, there's still some questions. Yeah, we have a lot also in our documentation and some example apps. And yeah, if there are more questions, either contact me directly or like go in our Discord. You can find like in the dev channel. You can find support.